Welcome everyone, and thank you for joining us for DigitalGlobe's lead webinar series, Learn, Engage, Act, and Discover. My name is Becky Schneider, and I'm the Regional Marketing Programs Manager at DigitalGlobe, and I'm also your host for today's webinar. Before we get started, I'd like to give everyone a few tips to keep in mind while viewing today's webinar presentation. First, all attendees are on mute. So to ask a question, please use the Q&A chat box feature that's located at the right-hand side of your screen. All of your questions will be answered at the end of today's webinar. Attendees have the option to view today's webinar in full screen. To view in the full screen mode, please click your full screen tab that's located at the top of your screen. And lastly, a link to today's webinar recording will be sent to everyone via email within the next 24 hours. Today's webinar is titled, Using High-Resolution Satellite Imagery for Large-Scale Mapping. Satellite-based remote sensing technology for map generation that contains geospatial information has increased due to its multiple advantages. This webinar will focus on the use of high-resolution satellite imagery for large-scale mapping and its various applications. Today's webinar will be presented by ADCC Vice President Nikhil Dakshindas. Mr. Dakshindas has a bachelor's degree in civil engineering and a master's degree in business administration and operation research. As a professional with 20-plus years of experience, he manages sales and marketing business development activities in Eastern Africa. So without further ado, I'd like to welcome Nikhil, and let's begin today's webinar.
Hello everybody, I am Nikhil Dakshindas, Vice President ADCC Group of Companies. We are working extensively in the last 17 years in the field of geospatial and remote sensing. Let me introduce my colleague Shreya Chandola, who will be along with me in the webinar. In the webinar, we will be presenting about a company, very minor details about a company, and then we'll be focusing on 4 case studies which we have undertaken using the satellite images. ADCC Group of Companies, we are a company based from India. We are having presence in Africa, about 4 countries in Africa, and right now we are operating in a Latin America, Central and South America continent as well. It's a company which is about 1,200 employees. We are working in 4 major verticals: geospatial services, engineering design services, which is related to the mechanical, energy systems and solutions related to the energy and electrical domain, and the application development on these above services. When I come on the geospatial services, we are majorly into cadastral mapping, that is land, utility, which has the energy, electricity, power, gas, municipality, about the municipality-based services, 3D GIS, that is LiDAR and photogrammetry, navigation, and we are highly using the imagery solutions from DigitalGlobe for all our geospatial domains. We have a different industry partners. We have tied up with different industry partners such as Intergraph, Autodesk, ESRI, where we develop an application on top of their solutions. Now I will like my colleague Shreya to take it from here for the initial projects. Yes, Shreya, please.
All right. Thank you, Nikhil, for the introduction. And hello, everyone. I'm Shreya Chandola. And let's start with current DigitalGlobe sensors. So the sensors that we have been using here at ADCC for various applications are WorldView 1 and 2, QuickBird, Iconos, and GeoEye-1. We're also hoping to use WorldView 3 soon, and we're hoping to suggest to our various clients to use WorldView 3 instead of aerial imagery because of its high resolution of 0.3 meters. So The chart here represents the various applications for which high-resolution satellite imagery is used. And here at ADCC, high-resolution satellite imagery has been especially useful in land management, water resources, agriculture, and forest management. So, high-resolution satellite imagery has proven to be a vital tool here in India and at ADCC. This is because India is still in the initial stages of understanding and managing spatial data. Issues regarding ownership of land, utility management, infrastructure development, and disaster management are problems that our government is tackling day in and day out. ADCC, through various government projects, is helping to tackle these issues by using various remote sensing and GIS techniques such as photogrammetry, thematic mapping, and regular updation of existing spatial data. Now, important issues that ADCC is addressing through our work in the utility mapping sector are issues regarding electricity and water distribution, cadastral and topographic mapping. So now, to begin with, utility mapping in the electrical domain, the Indian government has initiated a program known as the Restructured Accelerated Power Development and Reforms Program, also known as the RAPDRP, and it deals with the distribution and mapping of electricity. The goal of this project is to reduce distribution losses, which are currently at 25 to 30%. And to carry out asset inventory and also for system upgradation. So, the input data used in this project was a stereo pair of WorldView 2 imagery with a resolution of 0.46 meters and a stereo pair of WorldView 1 imagery also with a resolution of 0.46 meters. Now, land-based creation is done using these WorldView images, and basically with the help of field survey using DGBS, ground control points were collected, and the image here that you see here depicts land use, infrastructure layers, open spaces, and utility layers. And with a high-resolution satellite imagery is basically a low-cost and high-accuracy method for land-based creation, which is why we use this high-resolution satellite imagery. Now, so what we see here is that unique GIS plot IDs are generated and feature extraction and creation of base map is also carried out. And these steps are carried out with the help of high-resolution satellite imagery. The base is the high-resolution satellite imagery on which vector mapping is carried out, and ensuing map layers are based on this. So, also after this, two types of surveys were also carried out, which are the asset survey using GPS and consumer survey. Now, asset survey consists of mapping of substations, high tension poles, low tension poles, and distribution transformers. And the consumer survey basically consists of commercial and residential surveys. And its attributes are usage, load requirements, meter detail, etc. So now, using this as well as the features that were extracted using the high-resolution imagery, we come to these two maps. And these two maps illustrate GIS consumer data and electrical network of the same area. And the consumer data shows the plot IDs and attribute information related to those plot IDs. And the electrical network depicts its spread, and the triangles are representative of the electrical transformers. Now, this information, when coupled, helps us understand and manage the distribution of power effectively and efficiently. So, ADCC has been awarded similar projects in 6 states, which are Chhattisgarh, Maharashtra, Punjab, Rajasthan, Madhya Pradesh, and Uttar Pradesh. We've worked in a total of 62 cities and helped serve over 3.2 million customers spread over a network of about 52,000 running kilometers. Now, okay, so another project that we've been doing is topographic mapping for the MMRDA, also known as the Mumbai Metropolitan Regional Development Authority. Now, this MMRDA is the development authority of the Mumbai Metropolitan Regional Area, which covers about 11,000 square kilometers. And this project was basically carried out, it was like a disaster management project and was done for flood modeling and also for simulation, 3D simulation models. And for this, the very first step was to basically carry out a detailed topographic survey and investigation for the Mumbai metropolitan region and its hydrometric area using photogrammetric techniques, using high-resolution satellite imagery and field survey. Now, the initial steps included updation of existing maps and change detection. And the input data here were the original topographic map published by the Survey of India in 1975 and the WorldView 2 imagery with a resolution of 50 centimeters. Okay. The following process was employed in this project. It began with the acquisition of WorldView 2 satellite imagery. Field survey was then carried out using the GPS for the collection of ground control points. Image processing and photogrammetry techniques were applied on raw satellite data for orthorectification and generation of contours. And finally, GIS digitization of features was carried out. A total of 37 layers was extracted using WorldView 2 imagery. And field validation survey was also done in order to validate these layers. Now, in the output, what we saw is that in the last 35 years have seen significant changes in land use pattern, urbanization, transportation of water resources, etc. And what we can see from these slides here also is that irrigation structure has been added, which has resulted in additional canal network, right? And what we observed was that an increase of 27% of in the water bodies was observed in the updated map. The road network also increased by 27%. Streams increased by 22%. Power lines increased by 4%. And so the updation showed significant increases. And all of these changes were observed in a unit topographic map of 700 square kilometers, which shows that there have been drastic changes in the Mumbai metropolitan area. And such methods allow for data to be updated easily, accurately, and quickly. So use of high-resolution satellite imagery is a basic requirement for most of the projects here at ADCC due to it being a low-cost and high-accuracy method. Thank you. And now I'll hand it back to Nikhil.
Thanks, Shreya. Now we'd like to take over the case which we had done in the water distribution network. That was again for utility mapping, and this project we had done majorly in the state of Maharashtra. In water distribution, in India, the distribution losses are about 50 to 55% in the network. As we all know, water is a very precious entity, and to reduce these losses, this 24/7, that is the terminology given by state government, these projects are being undertaken in India. Some of the problems what are there in the water distribution are like, there is hardly any inventory of the assets as the pipelines are mostly underground. It is very difficult to map this pipeline, as well as there is hardly any record of mapping of the pipeline in a town or a council. there are about 40% unauthorized connection which the people, they pump out the water without paying any revenues. Also, due to this pipeline, due to wear and tear of the pipelines, lot of leakages takes place in the pipelines, which results in the water losses. Hence, this project was undertaken to study the existing system, analyze the system, prepare a detailed project plan for system enhancement for the urban local bodies. The intention of this project to supply the water 24 hours a day for 7 days a week. That's why it is known as 24/7 water supply scheme project. And in this project, calculating the projected figure, the water quantum for the next 20 years, it has to be planned, and the scheme has to be designed for the 20 years. The project involves different types of satellite images as per the requirement. Basically a stereo satellite image that is used when we design a water distribution network, or if it is just a consumer mapping and mapping of the existing assets, we use any of the WorldView 1 or WorldView 2 images. The process, it has a preparation, the map is prepared on the scale of 1:5000 as per the layers mentioned in the electricity project. That is building, infrastructure layer, utility layers, open spaces, playgrounds, these layers are mapped. There is a consumer survey involved, extensive survey involved, where number of people in a household, the water requirement of the household, usage of water, these things are studied and these are noted. There is a component of energy and water audits. It is done, water audit is done at different nodal points to estimate the losses between the 2 points. Energy audit is done to derive how much energy is required to pump out or pump in the water. Hydraulic modeling is taken for design of the distribution network. Now, if I combine this project outcome, now for a city which is like 20 square kilometer, a very small city, having a population of about 5,000 customers, this is the outcome of one town. Electricity is reduced by defining different fixed type capacitors, by changing the capacitors. Losses in that city before taking up the project was around 16%. Being a small city, there were less losses, and which was reduced to 2% using the leak detection. In the energy audit and water audit, we know the segments which are in losses, and we detect the leak in these segments, and this was reduced from 16 to 2%. As per hydraulic modeling, we have proposed a gravity main from dam using the 1 running kilometer of construction, which is about a saving of about 100,000 USD. This type of project we had undertaken in about 77 cities in the state in which we are working, that is in the Maharashtra, for one state. We are also working for different organizations such as Delhi Jal Board, which is for our capital city, New Delhi, and Veolia, that is a French company, which is distribution franchisee in couple of cities. So for these clients, we are doing this type of project. In this project, we are working since last 6 years. We have got different awards from the central as well as from the state governments. We got a Prime Minister Excellence Award in one of our water supply distribution projects, where we have reduced the NRW, that is non-revenue water. We are also having, we also got state award from our state government. Now there is a major project which is coming up in India, that is for the modernization of land records program. To give details of this, I will just like to give an outline of this land record in India. In India, the land parcel size, like in a village, which is having an area of about 500 hectares, easily you will find about 800 to 1000 parcels. So the parcel size, average parcel size in a village is less than a hectare. 80% of the litigations in the courts are due to this land disputes. Hence, the central government of India has taken up this project to introduce the transparency in the entire system, mapping and introduce the transparency of the system. The project scope is for computerization of the entire land records, record room management, development of activities, updation of parcels. Now, we would like to mention here that the map created in the land record department, usually they are about 50 years old, 30 years to 50 years old. They are hardly updated, as large quantum of updation is required in those maps. So one of the intention of this project was to undertake updation of the maps so that the map should match with the present ground conditions, and subsequently updation of maps in the coming times. Now in this case study, we are highlighting a project undertaken for a union territory, that is Silvassa, Dadra and Nagar Haveli, which is in the west part of the country. In this project, the area for this union territory is about 290 square kilometer, which has about 71 villages, and each village will be having 800 to 1000 parcels. This, as mentioned earlier, the last survey was done more than 50 years ago. Right now, with the department, they don't have the record for about 20 to 25% of the areas which is lost due to some natural calamities or due to some misuse of the data and all these aspects. This project involves various components like mapping, scanning and mapping of the land records, maps, establish a ground control network, primary, secondary and tertiary network over the area. It also involves orthorectification of satellite images, superimposition of the scanned maps over the satellite images and updation of the maps using the satellite images. Now here we would like to mention that when we update the maps using the satellite images, the survey and resurvey component of around 70% is reduced, 60 to 70% depending on the terrain is reduced. So in this process, it makes the process very fast. Input data, like here in this we use the multispectral as well as the mono images. Mono images for creating the DTM, DEM and multispectral for updation of the parcel maps. In these maps, some of the areas, like we are mentioning about the village or cadastral area, some of the areas which are not very clear from the images, due to there are very small polygons, these areas are highlighted and these are again resurveyed on the ground using the total station method. If I compare the data, what I had done from the satellite images and what area I have calculated from there, what area I have taken from their database, I can find that there is a variation of maximum 13% in both of the areas, and as per the NLRMP guidelines, the variation allowed is 5% in the area. So I can see that from the database, from the data what I have generated, I need to resurvey about 30 to 35% along with the obscure area. This survey has to be undertaken. Once these maps are prepared, once the parcel boundaries are identified, wherever required, we go for the field updations, field validations. Once these are confirmed, we can finalize the village boundaries, and similarly, it can extend up to the district or the county level. This project involves not only updation of the village boundaries, the parcel boundaries, but a provision where this project can be undertaken in future as well. So we develop a customized application where you can display the data, you can take the relevant information, special information, non-special information, and update the data for the further uses. As per NLRMP has mentioned that for undertaking this type of projects, different methodologies are proposed. And in this process, we are using the hybrid methodology, which is a combination of satellite images and the field survey. And we have observed that using this methodology, we can undertake the project very well and within the stated and the budgeted cost as well as in time. We would like to state here that we have undertaken a land records project in different components in 7 states in India. But it's the first place, the first union territory where we are taking all the entire end-to-end activities, and we believe that this project will act as a benchmarking project for the entire country in the space of land records. So that was from our side. We'd like to thank you for this time, and in case of anything, please let us know. Thanks, Bika.
Thank you, Nicole, for your wonderful presentation. At this time, we're now going to open up the Q&A portion of today's webinar. If you have a question for today's speaker, please type that question into the Q&A chat box feature that's located at the right-hand side of your screen. So, Nicole, thanks again for your wonderful presentation. And I had a couple of questions that came in during the live presentation. And
yes,
a listener would like to know, they're interested to know whether the data that's captured is manual or whether automatic data collection and classification methods are used.
Okay, and is it about some specific project or he's asking in a general one? Can I get it?
I think it's just in general. They didn't list a specific project.
No, in a general, I will say the data is captured in a semi-automatic ways, like for electricity net distribution surveys. We use the GPS. We had to go to the field to get the consumer information. Field intervention is necessary. We are using GPS and the iPhones to get the data collected from the site and use the same data. Similarly for the land records, the land projects as well. So it is collected in a semi-automatic way, neither totally manual nor totally automatic.
Thank you. Your next question is, a listener made a comment that the sizes of cities in India range from 10 to 500 square kilometers, and it's not possible to acquire fresh images for every project. How can the archived satellite images be used for land-based creation?
In this, the issue is that though the city size, there is a very variation of the city size, but as per the RAPDRP guidelines, they state that you can use the images which are 6 months older. And so every time, whenever you want the project, you don't require a satellite images. There are different methods in which the database can be updated. So as per the guidelines, we are supposed to use the 6 months older archive data for this type of projects.
Another question that came in is the listener would like to know, what purpose does change detection serve in the MMR area that is highly urbanized?
Okay. Now this project, basically there were 2 purposes of this project. Now first we would like to tell about MMR area, which is Mumbai is our commercial capital of India. Now for this project, the project was done for the creation of 3D simulation modeling. That was one. And second was to survey how extent of land use has increased. Because in the state of Maharashtra, about 40% of the population is concentrated on this MMR belt. And the belt is about 11,000 square kilometers. So there is a very high density of the population to study about the flood modeling, simulation modeling, as well as the extent of the urbanization of areas. These projects were undertaken by the department.
Your next couple of questions that came in is in regards to what you talked about for water distribution. And that first question is, a listener would like to know if you've mapped the underground pipelines. And if you have, how did you do this?
In this water distribution project, the main challenge is to map the underground pipelines. Because like in India, in electricity distribution, it is an overhead distribution, but water is something which is underground. So for this, a lot of extensive work has to be done along with the departmental people. They have the people who knows the parts of the pipeline. There are some automatic survey methods for mapping of the pipeline. There are some maps, the as-built maps present with the department. So again, this activity is combination of all the three, what I have just mentioned.
And your second question in regards to water distribution is a listener would like to know, besides DPR, what additional applications have been developed for this project?
In water distribution, in water distribution, what happens once we map the entire distribution network, then comes the billing component, online billing component. So this application has been developed by ADCC, where a customer can just access the bill to the municipal council, pay the bill online, they can log in the complaint online, and they get the complaint response within 25 hours. Otherwise, the same complaint is escalated to the next stage. So this type of applications has also been developed by ADCC.
So we're going to take a couple more questions before we close out today's webinar. And one of those questions is, how do you compare the status of land records in India with other developing countries in Africa and Central America?
I will say Central America is very much advanced as that of India. But if I try to compare that with Africa, in Africa, they are right now in India, when I mentioned in my presentation, about 70 to 75% are maps are ready at that 5,000 to 10,000 scale. But in Africa, these departments are lagging even though base maps. So we are in a process of creating the maps. Like we are working with the government in Zambia, where we are in the process of creating those base maps, that is the cadastral, the parcel maps with the government. And they are trying to implement NSDA, National Special Data Infrastructure type of setup, Africa. So Africa is just a step behind India in this purpose.
And your last question for today's webinar is, a listener would like to know, in regards to on what grounds or methodology can you say that hybrid methodology, which combines satellite data with ETS survey, is really the most cost economical and time saving?
Yes. Now in India, I think about 5 to 6 states have started taking this project. Now the case study I presented about Silvassa, that is the first state, the third state which is having the method of satellite images and the land surveys. Because initially a few of the states started with extensively survey method. But to cover an area, like for example the state which we belong, it's about 300,000 square kilometer. So by the time you complete 300,000 square kilometer of the area, the entire, again, the land holdings and everything will be changed. So it is a ever-endless job. So this is a method where we have experienced that we can reduce about 70% of the survey efforts. The demarcation of the land boundaries is done using the satellite images. About 70% of, when I say the field cost is saved, naturally the time frame as well as my total project cost, that is also saved. Coming back to aerial photographs, we have certain limitations in acquiring the aerial photograph. So none of the project, the state government, very few projects, they have started using the aircraft, but I don't think how they are going to get the permissions and when they are going to fly. But this is a method combining satellite data and the field survey that is running through, that is selling through, and most of the states will fall on this type of methodology, the hybrid methodology only.
So that's going to wrap up the Q&A portion for today's webinar. I'd like to thank Nikhil and ADCC for their wonderful presentation today, and I'd like to thank everyone for attending our webinar. If you'd like more information or if you have additional questions, I encourage you to reach out to ADCC or Nikhil directly. I have listed Nikhil's email address on the slide, as well as ADCC's website if you'd like more company information. That's going to conclude today's webinar. I thank everyone for attending, and we hope to see you at future events.